using the definitions of trig functions. My joke on here says sine gerene over cosine gerene equals tangerine. It's kind of funny. First of all, we're going to look at the definition of identities. These are equations that are true for all values of the variables for which the expressions are defined. So an example that you might recall from Algebra 1 is the square of a sum. So if we were to do box method or FOIL, x plus y times x plus y, we would get something that's x squared plus 2xy plus y squared. Likewise, over here on the right, we have an equation that whenever you distribute the 2, you get the right side, the 2x plus 6. So identities are just equations that are true. Reciprocal identities are two identities whose values are reciprocals for each other. So one example would be 2 and 1/2. Reciprocal is where you flip it. 2 is just 2 over 1. So if you flip that, you get 1 over 2. Same thing with sine and cosecant. We have y over r and then r over y. So those are reciprocals. So some definitions here. Reciprocal identities. The reciprocal of sine of theta is 1 over cosecant of theta. Again, that's because we have this reciprocal identity with y over r and r over y. If you need to find cosecant, secant, or cotangent in your calculator, then you're going to use the sine, cosine, or tangent button, and then you're going to use your inverse key. So some of your inverse keys might be x to a negative 1, or maybe it's 1 over x. If you're having trouble finding it, just ask your teacher. In this example, we're going to find the function value. So for number 1, it's asking us to find cosine of theta when secant of theta is 5/3. Since cosine and secant are reciprocals, all we have to do is flip the 5/3. In problem 2, we're finding sine given cosecant. So that's just going to be flipping our fraction. But here we are going to have to rationalize because we have a square root in the denominator. Pause your video and try number 3 on your own. Signs and ranges of function values. We've gone over the left side of this figure before. All functions are positive in quadrant 1. Sine is positive in quadrant 2, and therefore so is cosecant. In quadrant 3, we have tangent is positive, and therefore so is cotangent, because again, they're just reciprocals. It's the same positive or negative sign, just the fractions are flipped. And then in the fourth quadrant, cosine and secant are positive. Again, we have I don't remember if I said all students take charge or all seniors take charge. We're going to say all students take charge just to include everyone and not just our seniors. Okay, ranges. So a range is just what your output can be. So what numbers can sine of theta be equal to? What numbers can cosine of theta be equal to is kind of what we're asking here. So looking right here at sine of theta, this tells me that sine has to be between -1 and 1. It can equal -1 or 1 because I have equal signs on my less than symbols here. So sine of theta cannot equal 5. It's got to be between -1 and 1. Cosine is exactly the same. So now let's talk about, let's just jump down to secant and cosecant really quick. Since sine and cosine have to be somewhere between -1 and 1, so I don't know, let's just have an example. Maybe it's 1/2. So if we have cosine of theta being equal to 1/2, then secant would be the reciprocal. So if we flip that, we would get 2. So it makes sense that secant has to be bigger than 1 or less than -1. So secant could be equal to 5. Same thing with cosecant. It's going to have to be either less than -1 or bigger than +1. Tangent and cotangent can be any real number. Your homework may actually write these ranges in a different way. So they might not write -1 less than or equal to cosine theta less than or equal to 1. They might write it as a bracket and then -1 comma 1 with a closed bracket. That just means all the numbers between -1 and 1, including -1 and 1. Those brackets mean including. For tangent and cotangent, we've got -infinity to infinity. That just means all the possible numbers. For secant and cosecant, it's going to look like -infinity all the way up to -1, so that's what the left one is saying, and then 1 all the way to positive infinity. I know that I have zeros on your notes, but I just changed it so it would be like the 1 and -1 here in this example. So whenever your homework gives you some different notation like this, make sure you come back to this part of your notes and recall what they mean. In this example, we're going to identify the quadrant, or possible quadrants, could be more than one, of an angle theta that satisfies the given condition. Okay, so for problem A, we have sine is greater than 0, so sine has to be positive, and tangent is less than 0, so it has to be negative. This is something that I'm going to sketch out, so go ahead and draw your quadrants and label them all students take charge. Now let's look at where sine is positive. It would be positive in the all quadrant, because all of the functions are positive, and in the sine quadrant. So we have positive sine up here. Next, we need to look at where tangent is negative. Well, it's not negative where we have our t, and it's not negative where all of the functions are positive, so we've got these two quadrants here. The one quadrant that satisfies both the pink and the yellow situations would be quadrant 2. For our next problem, we have cosine theta is less than 0, so cosine is negative, and secant is also negative, less than 0. Since my all students take charge doesn't really use secant, let's just think back that secant is just the reciprocal of cosine. So really, we're just saying twice that cosine is negative here. So looking where cosine is negative, that would be on quadrants 2 and 3. Secant is also negative in quadrants 2 and 3. So those are our answers. In this example, we're going to determine the sine of the trig function of an angle in standard position with the given measure. Again, I think it's just a great idea to go ahead and draw the angle. That'll really help us understand what's going on with our trig functions. So here's my angle, 87 degrees, and then I'm going to go ahead and put in all students take charge. And we're in the all quadrant, so we know that all of our trig functions are positive for this angle measure. For problem B, we've got 300 degrees, so go ahead and draw your angle, and then put in all students take charge. Since we're in our fourth quadrant, we've got C, which means that cosine is positive. So cosine and secant are positive, and sine, cosecant, tangent, and cotangent are all negative. Problem C, our angle is negative 200 degrees. Don't forget that that means that your angle is going to go down when you draw it. All students take charge. Since we're in the second quadrant, we've got sine and cosecant are positive, and then cosine, secant, tangent, and cotangent are all negative. Decide whether each statement is possible or impossible. So make sure you're looking at your ranges in your notes here. So problem A says that sine of theta is equal to 2.5. Since the range of sine is between -1 and 1, and 2.5 isn't in that range, then this is impossible. Problem B, we have tangent of theta equal to 110.47. Our range for tangent is any real number, so we're good here. Just a reminder, it's not a real number if there is an I involved. Imaginary numbers are not real. Problem C, we have secant equal to 0.6. Our range for secant is either less than or equal to -1 or greater than or equal to +1. 0.6 is in between there, so this is impossible.